Okay, let's give you guys some more practice. So here, find the derivative of y equals 1 over x. Me asking you to find out the derivative is like me asking you to find dy by dx. Okay, so find dy by dx of this thing here. So to do this, start out by sketching this graph here. So your reciprocal graph will look something like this. And then set up your A and B. This is your A, this is your B. And then inside your mind, say to yourself, the gradient that exists between A and B is given by x plus h, take away f of x, and then divided by h. Okay. So start out by saying the gradient that exists between A and B is given by this. But then as you decrease h, hang on. So your right angle triangle is here, and this is your h here. And then your next step is to say, as you decrease h, then as h heads towards 0, then the true gradient dy by dx here. Remember, this here is your true gradient. This here is just a notation. Notation means it's just the way we write true gradient. So this is this is your true gradient. True gradient equals the limit as h tends to 0 of this thing here, and then take away f of x. Now f of x here over h. Okay, so start out by saying the gradient that exists. Start out by saying the gradient that exists between a and b is given by this, and then the thing is, when you take the limit as h tends to 0, then that will give you the true gradient. And the true gradient, which is this here, the true gradient is given by this. Okay, so now if you want to know the true gradient, which is dy by dx here, the true gradient is when you remember our equation is y equals 1 over x. Now if you put x plus h into here, then that will give you this, and then take away, which is this take away here, take away f of x. Remember, our f of x in a way is like this. So this is taking away f of x. So this is our f of x, and this here is our f of x plus h here, and then divided by h, and then take the limit as h tends to 0. So that will take you to this stage here. Okay, and your job is to do the rest now. So take the limit of this, and somehow now it just really boils down to algebra now. Somehow take the limit of this as h tends to 0. As a clue, merge these two fractions together. So in order for you to add or take away fractions, the two denominators here have to be the same. So maybe times top and bottom by blah blah blah, and merge these two together, and then that will give you one fraction over h, and then visualize it as ab divided by h, and then h gets multiplied to the bottom, and then blah blah blah. Hopefully this thing will somehow, well, take the limit of this whole thing. That's your job. Okay, so now the true gradient is given by this here, but then you've got to do the rest. So press pause and have a go. Okay, so to do this here, hang on. So to do this here, yeah. So now it's just a matter of getting the two denominators to be the same. Merge these two fractions together. But in order for you to take away fractions, the two denominators have to be the same. So here, times top and bottom by x, and then over here, times top and bottom here by x plus h. Okay, x plus h, and then that will then become this. So this fraction here becomes this, and then this whole thing here becomes this. Okay, and then the next step, the two denominators now are the same. The two denominators here are the same. So now you can just merge these two fractions together. So it'd be this, take away this thing here over this. So that will take you to here. Okay, and then the next step, whenever you have a fraction within a fraction. So here you've got a fraction here. divided by h. So in effect, this is like a fraction. This whole thing here is like a fraction. You've got one thing here over another thing. Whenever you have a fraction within a fraction, so whenever you have a over b all over c, then visualize it as a over b divided by c, because this is, you've got this thing divided by this thing. So get this thing here divided by this thing. So this, in a way, whenever you divide a fraction, it gets multiplied to the bottom here. So so basically visualize this as this divided by this. So that's this divided by this. Okay, visualize it like that, and then notice that you've got x, take away x here, so these two will kill off each other, leaving you minus h. Okay, and then well, at the moment this thing exists in a bubble here, so this gets, whenever you divide a fraction, it gets multiplied to the bottom. So this h here is right here, and this bubble here is right here. Okay, and then the next step is to visualize a minus h as minus 1 in a bubble times h. Visualize this thing here as these two separate bubbles here, and then you can see that here you've got a bubble multiplying another bubble here. So these two will kill off each other here. Okay, leaving you minus 1 over blah 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 down here. Okay, now you can take the limit as h tends to 0. Nothing breaks down when this, well, as h tends to 0, this becomes 0 here, and then that will leave you with minus 1 over x squared. So this is your final answer here. dy by dx is minus 1 over x squared. Okay, so if you look at your original graph, it will look like this. And notice that the gradient is always negative. So for example, if you're here, you can see that you've got a negative gradient. Even if you're here, you've got a negative gradient, but the gradient gets steeper and steeper. If you're here, notice that the gradient is negative. Even if you're here, the gradient gets steeper and steeper, but it's still negative. Look at this here. The gradient is still negative. The gradient here, it's really steep here. Now it's getting a bit shallower. It's getting a bit shallower here. But there's still a negative gradient. And then here is still a negative gradient, but it's getting shallower and shallower. It's still a negative gradient. So your gradient graph should always be negative. Okay, and then when you look at your gradient graph, which is this thing here, when you plot this graph here, it will look like this. And see, the gradient is always negative. Let's say you're here, the gradient is negative 0. Blah blah blah. And when you're here, the gradient is negative 2. Okay, so if you look at around here, okay, when x is around there, you can see that the gradient here is roughly minus, well, it's roughly here. Okay, well, you can see that because when looking at your original graph, the gradient is always negative. And as you head towards 0, it gets really steep. And when you look at the gradient graph, you see as you head towards 0, the gradient graph, well, remember when you're looking at the gradient graph, it's a straight reading. So here, around here, the gradient is negative 4 point something. It's a straight reading. So when you're here, the gradient is negative 2. Okay, even if you're on the positive side, let's look at your original graph. When you're here on the positive side, the gradient here is still negative, and it's really, when it's near 0, it's really steep, negatively big. Okay, look at your gradient graph. Look, when you're near 0, the gradient is negative 4 point something. It's big and it's negative, and then as you head further out on the right hand side of your original graph, the gradient gets smaller and smaller, but it's still negative. And when you look at the gradient graph, it's getting smaller and smaller, and it's still negative. So everything makes sense. Okay, so well, I hope you understand it.